My name is Hartsell, and we're going to talk about atoms and molecules today. Okay, this science experiment, the supplies for it are a small glass, baking soda, tap water in the glass, a 9-volt battery, 2 9-inch pieces of insulated wire, and the wire itself must be copper, a pair of scissors, and some tape. And it calls for electrical tape. So you'll see that the wires on this side that are clear like this one, I put them on the negative and the positive and covered it with my electrical tape. Okay, now atoms, this is the introduction. Atoms and molecules make up everything that surrounds us. Individually, they are simply too small to see. However, you can distinguish between the different kind of atoms and different kind of molecules by examining the substances that they make up, as well as how those substances change. In this experiment, we will observe molecules changing into atoms and atoms changing into molecules. By observing these changes, you will learn about the difference between atoms and molecules. So, I've got 3/4 of water in my cup. And I'm going to add a teaspoon of baking soda. And I'm going to stir it up. Okay? I used my scissors and I took the insulation off the wires on both sides. Then I put the copper on the negative and positive on this side. Make sure when you take this insulation off that a parent helps you do it. Don't do it on your own when you're working with scissors or a knife. Okay, now, if you see my water's cloudy, okay, I'm going to put my wires in my baking soda, okay? And when I put my wires in, you're going to see it bubble, all right? Okay, now I'm going to tell you what happens, okay? When I immerse them into the water, the baking soda makes them have bubbles, all right? And while these bubbles are bubbling, let's see if the water changes or stays the same, okay? So, atoms are the smallest stable unit of matter in creation. Atoms are so small that you cannot see them at all. They are so small, in fact, that roughly 100 billion atoms are contained in the head of a pin. If we can't see them, then how do we know they exist? Lots of experiments have been done that can only be explained if you assume that atoms exist. Thus, there's a lot of indirect evidence that atoms exist. All of this indirect evidence leads us to believe that atoms are indeed real. And you can really see the bubbles coming up now on the negative and positive side. So we'll just keep an eye on it and see what happens. So this is our what happens to the ends of the wire. When you strip the insulation off the ends of the wire, you saw the familiar red-orange color of a copper wire. Yeah, well, it turns out that copper is a type of atom. Thus, the copper that you observed in the wire was really just a bunch of copper atoms lumped together. You couldn't see the individual atoms, but when billions and billions and billions of them are put together, you can see the substances that they make. When you have billions and billions and billions of copper atoms, you get the flexible electricity conducting red-orange metal called copper. We currently know that there are about 109 basic kinds of atoms in creation. This number increases as time goes on, and every once in a while, scientists will discover a new kind of atom. In a few years, then, the number of basic kinds of atoms in creation will probably be a little larger. That is why I say about 109 different kinds of atoms. If this were the end of the story, creation would be pretty boring. After all, if everything you see is made up of atoms, and if there are only about 109 different kinds of atoms in creation, then there would only be 109 different substances in creation, right? Of course. Although God used atoms as the basic building blocks of creation, He designed those atoms to link together to form large building blocks called molecules. Molecules are two or more atoms linked together to make a substance with unique properties. It turns out that the water that you used in the experiment is made up of molecules. Now, although molecules are bigger than atoms, you still cannot really see them. Thus, the water that you see is made up of billions and billions and billions of water molecules, just like the copper wire is made of billions and billions and billions of atoms of copper. A water molecule is formed when an oxygen atom links together with two hydrogen atoms. When these atoms link together in a very specific way, the result is a water molecule. Now we are ready to really discuss the results of the experiment. When you fill the glass with water, you are filling it with billions and billions and billions of water molecules. When you place the wires which were connected to the battery into the water, the electricity from the battery began flowing through the water. When this happened, the energy from the electricity flow actually broke some of the water molecules down into hydrogen and oxygen, which began bubbling out of the water because hydrogen and oxygen are gases. This is an excellent illustration of atoms and molecules. Each water molecule is made up of two hydrogen atoms and an oxygen atom linked together. When these atoms link together in that way, an odorless, colorless, tasteless liquid we call water is formed. When electricity is used to break the water molecules down, hydrogen and oxygen are formed. Hydrogen is an explosive gas with an acrid smell, while oxygen is the gas that we breathe in to stay alive. Think about that. Oxygen and hydrogen are each gases with particular properties. When they link together, however, these individual properties are lost and a new substance is formed. If the links between these atoms are broken, then the atoms separate and go back to their original forms. So in the water portion of the experiment, you saw a molecule, water, breaking back down into its constituent atoms, hydrogen and oxygen. Well, when you pulled the wires out of the water in 10 minutes, you saw the wire connected to the positive terminal of the battery had turned a bluish green color. In this case, the copper atom in the wire interacted with water molecules and baking soda molecules, aided by the energy contained in the electricity. The result is a blue-green substance called copper hydroxycarbonate. Copper hydroxycarbonate is formed when a copper atom links together with oxygen atoms, carbon atoms, and hydrogen atoms. In this experiment, the hydrogen and oxygen atoms came from both the water and the baking soda. The carbon atoms came from the baking soda alone, and the copper atoms came from the wire. In this case, then, you observe atoms, copper, linking up with other atoms, oxygen, carbon, and hydrogen, to make a molecule, copper hydroxycarbonate. Interestingly enough, copper hydroxycarbonate is the same substance that you see on many statues, such as the Statue of Liberty. You see, if a statue has copper on it and it is exposed to the weather, a process similar to the one that you observed turns the copper atom in the statue into copper hydroxycarbonate. As a result, the statue turns green, just like one of the copper wires did in your experiment. So, if you look in the glass, you'll see the water has turned blue on top. It is from what? The copper hydroxycarbonate. Okay? So now we're going to take the wires out of the water. It's been a while. And you'll see the blue wire is, what do you think? Negative or positive? It is positive. It's on the positive side of the battery. The regular copper wire didn't change colors, and it's on the negative side of the battery. So, that's the end of our experiment for today. I buy these, every experiment that's in this book. It's a Apology and Exploring Creation with Physical Science book by J. Wiles. And every experiment, you buy your supplies at the Dollar General store, or you can buy them at your local grocery store. So, if you want to do these experiments and they're fun, you can pick up your supplies at any store. Talk to you later.